Patrick Cook here. Hey, thanks for joining me in the next session of our tutorial series around the lines of a Mandelbulb 3D animation project. So I've just had a sip of coffee. I feel better. I'm ready for more. I hope you are too. Let's talk about this camera thing here. All right, we have 3 different cameras that we can choose in the Mandelbulb software. We're on the Navigator, and this is the panel that we need to pull down. And here I have 3 different cameras. I've got a standard, I got a rectilinear, and I've got a panoramic. Now, before I start bopping around and changing these things, it's important to understand that what you're attempting to do is to get a good looking graphic, all right? And that will be the basis for either your animation or to render out a high detail still. You can do some absolutely amazing stills with this software. It really doesn't have a resolution limit. The limit is in the amount of memory that your computer has, and your CPU power. That's really your limit. The wonderful thing about the Mandelbulb 3D software is that you don't have some big commercial entity who has decided that you're only going to get, 1920 by 1080 resolution unless you pay them $300. With the Mandelbulb 3D software, you can go as big as your computer can handle, which is really a cool thing. Now, because you have that kind of capability in terms of resolution, you want to really be able to leverage the camera, the simulated camera of the Mandelbulb 3D. Now, we had talked about the field of view, all right? We talked about that in the previous session. Now, and I was showing you that field of view set on a standard camera. Now, basically, a standard camera will have what are called barrel distortion, and a standard lens in terms of photography. The optics within the optics of that lens, they have an artifact that's called barrel distortion. Let's get our whiteboard up here. All right, so let me get my stylus here. So barrel distortion. If we're looking at we're looking at a rectangular box, okay? With a standard lens, it will tend to distort the image. I'm exaggerating here. And this is called barrel distortion. If I have a flat pancake lens, all right, maybe some of the more compact digital cameras. These types of lenses tend to have less internal optical control, and they tend to give you barrel distortion. Now, most photo editing software will correct that. It'll correct that barrel distortion. And so each camera and its lens, its lens models, they all have a characteristic where they will distort the image, and then the software will try to correct that image and eliminate the distortion. All right. So the point I'm making is that this is a standard lens. It's either a cheap lens or it's a lens that simply does not have the mechanical capacity to have enough lenses in there to be able to fix the distortion within the mechanical optics itself. So that's a non-photographer's description of what this barrel distortion is, which is associated with an optics. That's your standard lens right there. Now I can prove this barrel distortion by putting this up to, say, 100, the field of view. So here I'm experiencing barrel distortion because I have made the field of view so extreme that it's distorting. Let's go back to 50, and now let's set this to rectilinear. Now, rectilinear basically is a lens that that makes an effort to eliminate the barrel distortion. All right, so let's get our whiteboard back up here. Get my stylus. All right, and let's take my rectangular object here. So a rectilinear lens will try to output straight lines, whether they're vertical or horizontal, doesn't matter. Most digital camera lenses will attempt to correct the barrel distortion, and those are typically referred to as rectilinear. Now let's see if I can show this here. So I'm set for rectilinear. Let's go to 20. All right, there's my scene, field of view 20, rectilinear. Let me switch over to standard. All right, not a whole lot of change there because my field of view is so large, I don't really see much difference. All right, but let's go to 50. Now there's my standard camera. It's kind of mislabeled. It really should more be like lens. Standard camera. Here's my rectilinear. Not a whole lot of difference there. All right, let's go to 90. There's my rectilinear. There's my standard. You see? Now we're getting a little bit of an example here. Standard, rectilinear, standard, rectilinear. What the software is attempting to do is to simulate the optical behavior of a rectilinear lens, which makes an effort to eliminate or reduce the barrel distortion that you would get with a standard lens. So here I actually have more distortion in standard at 90 millimeter field of view, my rectilinear. So rectilinear will be helpful in attempting to reduce or eliminate curves. When you have a straight line, you have straight edges in your fractal image. Rectilinear will attempt to keep those lines straight. Standard will not attempt to keep those lines straight. Now let me just say this, that your standard and your rectilinear choices can make a huge difference in your fractal graphic, because there may be situations where you actually do want distortion. Personally, I think that this graphic looks better in a standard lens, which does not attempt to straighten out the lines, than in this rectilinear. I think standard looks better. So it's more of an artistic choice, but you do have that choice, which is pretty cool. Now, in modern graphic softwares, you've got nth control over every aspect of your simulated camera. You don't here. You really only have two camera controls. You have the field of view and you have standard or rectilinear. And then, of course, you have your position, where you position the camera, but I'm not talking about positioning. I'm talking about the actual structure of the simulated camera. You only have a few controls pertaining to the camera in your Mandelbulb3D, but those can actually be leveraged to be very creative. Not much to talk about with the panoramic. The panoramic will give you a 360-degree view of your Mandelbulb fractal object. You see here's something that looks familiar. this part right here. All right, go back to rect. There we go, right there. Go back to standard right here. All right, so the pano usually always needs some sort of a third software tool that will take this and utilize this pano for a 360-degree Mandelbulb image or animation. So the Mandelbulb3D application will actually allow you to produce or output panoramic to be utilized in constructing a 360-degree video. You can put them up on YouTube, and you take your iPad and you can do that sort of thing. All right, but the Mandelbulb3D does allow you to output a panoramic image. All right, so that's enough for this session. Now, the next session, I want to talk about this far plane here. So we're going to put that back on standard, and we're going to go ahead and end this session right here. I'll see you in the next session. We'll talk about the far plane, and I think you'll find that quite interesting too, and artistically interesting. So I'll see you in the next session.